Hello viewers, welcome back to my channel Shraddha's Physics. We are continuing our lectures with the complex analysis. Today our topic is the function of complex variables. Then we will see the limit of the complex function, continuity of the complex function, and finally the differentiability of the complex function. Now let us see the function of complex variables. Suppose my complex number z equal to x plus iota y, z equal to x plus iota y. For this x and y are the real variables. If for each z belonging to a suppose region, I am saying suppose a region R, this x y are belonging to this region R or z belongs to this region R, then there is a unique complex number, suppose w, then we can say that this w can be defined as the function of z, okay, or this function of z is I am writing, suppose this is expressed as in the form of u plus iv, where u and v are also the real numbers. So, this function w equal to u plus iv, it is a complex number, that is this function w equal to u plus iv of the complex number z equal to x plus iy, it is defined in the terms of u and v for this u xy and this v. This u means here you can see that this f of z means z is the function of xy, this z is the function of xy. So, here in place of u plus iv, I can write this u is the function of xy and plus this iota v of xy, this is your v of xy, clear. So, to specify the complex function to the variable function, the two variables functions required, that is here I am saying z equal to x plus iy. If I represent this in the form of the function of z, where z is the function of xy, so this is also this f of z is the function, it is a complex function and we can write it as f of z equal to u of xy plus iota v of xy, clear. Here I am writing this more precisely, that is this function z, that is the function of xy, it is equal to u of xy, this is the function of xy since z is the function of xy, plus this is iota v of xy, okay. We can define like this. So, for example, suppose it is been given that this f of z, suppose this f of z that is equal to x square minus y square plus 2 iota xy, okay. Suppose it is given that this function of z equal to this much. So, here you can see that u belong to the real part. So, here this x square minus y square is u, or I am writing here this u equal to x square minus y square, and here v equal to 2xy, because in the imaginary part except this I, this will be 2 into xy, 2xy. So, here u equal to x square minus y square and v equal to twice of xy. Or simply this function can be written as, this will be nothing but your z square, or if I will split this z equal to x plus iy. So, this x plus iy whole square, this will be x square, iy whole square means I square is your minus 1. So, that will be minus y square, again this will be 2yxy. Here you can see that this z equal to x plus iy, it is in the form of f of z, that is here I am considering z square. So, that is the function f of z equal to z square, it is written as x square minus y square plus 2 iota xy, that is here u equal to x square minus y square and v equal to twice of xy. But here in place of this plus 2 iota xy, in this place plus 2 iota xy, if I will write this in place of plus, I will write minus, that is here I am writing this f of z equal to, this f of z equal to x square minus y square minus 2 iota xy. Here you can see that this is the z star whole square, okay, this will be x minus iy whole square. So, we cannot define this function in terms of z, okay. My point is, if I am not defining this f of z in terms of z, here I am defining this in terms of z star, not in the form of z. So, this is not the function of complex variable, clear. Now we will see the limits of complex function. Suppose the function that we have considered, that is w equal to f of z. Okay. W equal to this f of z, it is defined at all points in some neighborhood of z equal to z0. Okay. It is defined in some neighborhood of z equal to z0 except at z0. Except at z0 we can define this function everywhere. So, this if f of z it approaches w0, if it approaches w0, okay, as z approaches, when z approaches z0, then w approaches w0. Okay, this is not exactly z0, because I am saying that if this function is defined at every points in some neighborhood of z equal to z0 except that z equal to z0. Okay, except z0, at every point the function is defined, then we can say that this limit, simply I am writing this limit z tends to z0 f of z, this value should be equal to w0. Okay. So, then we can say that the limit of, this is the limit of the complex function. Suppose I am writing for example, this is limit of, suppose we are going to calculate this limit at z tends to I. So, at this point we are going to calculate limit z tends to I f of z. So, here f of z is given, f of z equal to, suppose this is z square minus z minus 1. Okay, this is z square minus z minus 1. So, if limit z tends to I, then I can say that this will be limit z tends to I, this will be z square minus z minus 1. Okay, in place of z if I will put I, this will be equal to I square minus I minus 1, I square will be minus 1. So, this will be minus 1 minus I again minus 1. So, that will be equal to minus 2 minus iota. Okay. So, this is called the limit of the function. Okay. This is the example of the limit of the complex function. This is the complex function. Okay. So, it means that except at z equal to I, means at this I point the function is not defined, but when z will approach to I means at every point of near to I this value exists, but except this point I. Okay. Except this point I, the value does not exist. Now, we will see the continuity of the complex function. Suppose the complex function, this f of z, it is said to be continuous. Suppose this is continuous at the point z equal to z0, it is continuous. Okay. Suppose this is continuous at z equal to z0. Then if, suppose I am considering this, if f of z0 exists, if this f of z0 exists, then we can say that the limit z tends to z0 of f of z, that will be must equal to f of z0, or we can say that the value is finite. Okay. If this value will be finite, we can say that the function is continuous in nature. Suppose for example, if I will consider, suppose for example I am considering our function is, it is given f of z equal to, suppose z square plus 3 divided by z square plus 4. Okay. Suppose this is continuous, we have to check the function is continuous at same z equal to I point. Suppose it is continuous at z equal to I point. Then we can write this limit z tends to I can write limit z tends to I, z square plus 3 divided by z square plus 4. So, that will be equal to, if I will put the value of z, that is I, then this will be equal to I square plus 3 divided by I square plus 4. Okay. So, this I square is minus 1 plus 3 divided by this minus 1 plus 4. So, 3 minus 1 is 2, 4 minus 1 is 3. So, our answer is 2 by 3, which is finite. This value is finite. Okay. So, we can say that the function is continuous at z equal to I. But here you can see that our z square plus 4 is here. So z square, if I put z square plus 4 equal to suppose 0, it means that z square equal to minus 4 or z equal to the root over of plus or minus root over of minus 4. So that will be plus or minus 2i. This will be plus or minus 2 iota. So here I can say that if I will write this limit in place of z tends to I, if I will put limit z tends to plus or minus 2i. Okay, if I will put limit z tends to plus or minus 2i f of z, so here you can see that in place of z square plus, if I will write in place of z square, if I will put plus 2i or minus 2i, then this will becomes minus 4. Okay, 2i square means 2 square is 4. So this will be I square, whether it may be I square or minus I square. So this will becomes minus 4, again this will be plus 4. So minus 4 plus 4 becomes 0. So something divided by 0 goes to infinity. So it means the value is infinite when we will put the limit plus or minus 2i. Or I can say that the function at plus or minus 2i, it fails to be continuous. Okay. So the final conclusion is that when we are putting this limit, that is for the function is finite, when we will put the limit for which the function remains the finite value, so then we can say that the function is, this complex function is continuous in nature. When you are given, suppose you have to check for limit z tends to infinity, suppose any function f of z. So in that case you have to consider simply z equal to suppose 1 by t. So when z tends to infinity, so when z tends, here it is given z tends to infinity. So here in place of this we can write t tends to 0. So when t tends to 0, we can put z tends to infinity. So this is simply nothing but limit t tends to 0, the function whatever, this is in the form of z, so we can convert it in the function of t. Okay. Now we will see the differentiability of the complex function. So a complex single valued function, suppose a complex single valued function, that is f of z, it is said to be differentiable in some neighborhood of z if the condition is, if limit delta z tends to 0, delta z tends to 0, f of z naught plus delta z minus f of z divided by delta z exists. Okay, the function will be differentiable if limit delta z tends to 0, f of z0 plus delta z minus f of z divided by del z exists. So this is nothing but, this expression is nothing but df by dz. Okay, this is nothing but df by dz, or simply we are representing this as f prime of z. This f prime of z is nothing but df by dz, and this is equal to this much. Okay. So to understand this, let us consider the complex function. I am writing the complex function f of z equal to, we are writing f of z, that is equal to x plus 2iy. Okay, this is suppose f of z equal to x plus 2iy. So now if I write this function, that is this f of z suppose plus delta z minus f of z divided by delta z. This is the differentiable. I am differentiating this complex function, that is, this is nothing but df by dz I am writing here. So this will be equal to, that is in place of z plus delta z, you know z equal to, in place of z plus delta z, you can see here, if I write z plus delta z in this bracket, then this x plus 2y becomes x plus delta x and plus 2i. In place of y I can write, this will be y plus delta y. Okay, again this minus f of z, so this will be minus x minus 2yy. So this will be minus x minus 2yy divided by this delta z is nothing but delta x plus iota delta y. Okay, so here this x get cancelled and 2iy, here if you will multiply this, this will be 2iy plus 2iy and this will be minus 2iy. This will get cancelled. So, the remaining term will be equal to delta x plus twice of iota delta y divided by delta x plus I delta y. Okay. This will be delta x plus I delta y. This is the differentiability of the complex function. Now, if delta y tends to 0 or if delta y equal to 0, in the limit delta x tends to 0, then the value of the differentiable function is, let me write here again, this is delta x plus I delta y divided by delta x, sorry, this is 2y delta y divided by delta x plus I delta y. Here I am writing limit delta z tends to 0 means delta x tends to 0 as well as delta y tends to 0. For example, if I will first consider that if delta y equal to 0 and delta x tends to 0. Okay, when delta y exactly 0, then in that case we can write limit, in this case we can write limit delta x tends to 0, so that this will becomes 2y delta y and I delta y. These two terms in the denominator and numerator, since delta y equal to 0, we can write simply this will be delta x divided by delta x, which get cancelled and this value will be equal to 1. But when I am writing delta x equal to 0, this is your first case and I am writing in the second case. So, in this second case, so here delta x equal to 0 and delta y tends to 0, in that case limit delta y tends to 0, in that case we are putting delta x equal to 0. So, I am writing simply this will be 2y delta y divided by delta y. So, delta y get cancelled, the remaining term will be 2 into I. Okay. So, here you can see that there are two different values, one is, first is 1 and the second is 2 iota. So, here you can say that this derivative f prime of z doesn't exist. Okay, this doesn't exist. Clear? Because the limit is not unique, that's why it doesn't exist. So, this is all for today. If you have any query, you can ask me in the comment section. If you like the video, can give a like. Thank you.